All right.
All right. People are in the chat. Hello, everyone. Jason here. If you're tuning in and not sure what you're seeing, this is the monthly meeting.
All
right, so someone needs to mute their YouTube. Let me mute you, Brian. Mute you. So if you're watching YouTube, let me bring up the volume. All right, sounds like it's gone. Good deal. And my computer is telling me it's warm in here. Yes, it is. I feel like I'm a little laggy here. Are we on Zoom? Corey, you're not on Zoom. But here in a little bit, I'll drop the Zoom link for everyone to join. But in the beginning, we're just going to have kind of the normal format. Club officers, board members, etc. will present things. Kevin has a really fun presentation he's going to get into. And then second half, we'll open up Zoom for everyone else to jump in, ask any questions, share anything they'd like. We just require pants.
We have to answer questions? Oh, crap.
We need pants?
I mean, I guess...
That's the rule, man. Brian gets up and goes away.
If we need pants, that means Schaefer's out of here.
Yeah, that's hilarious. That's hilarious. Well, you guys want to? We got. Oh wow, we got 28 people watching. Looks like you guys want to get started.
Yeah, let's get started.
All right. Well, let's get started. Hi, everybody. I'm Kevin in 6VLF. Thanks for joining us tonight on the Vaca Valley Radio Club with our virtual meeting. And a few of our board members and some of our officers are on the road. They're on vacation. They're not able to be here for whatever reason. But tonight, I think what we'll do real quick here is we're just going to say hello to everybody, and we're going to open with the Pledge of Allegiance, and then we're going to move right into it. Is that okay with you guys? Just say yes. Okay. Let's get ready. We'll do the Pledge of Allegiance first. All right. Ready? Go. I pledge of allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right. Man, that looked really good on YouTube. I hope it sounded okay. Great. Well, let's do this. Let's start with hey, Doug, do you have anything for us tonight you'd like to share? We got to unmute Doug's mic, though.
I do not.
Oh, you don't? Okay. Well, for those of you who don't know, Doug's our vice president, and he does a great job of sending out emails and keeping us informed and things of that nature. So, Doug, if you don't have anything, that's okay.
You know, that's the way the world is operating right now.
Okay. Well, very good. And what we'll do now is move on to KB0A. Brian, he is our treasurer. Do you have anything to report for us tonight, Brian?
I just want to say that I appreciate all of the folks who I notified that their dues were due, and they promptly responded.
Very good.
So that was great. So we're doing good. We have 83 members, and I thought Jackie did a great job on the net the other night.
Oh, yeah. I thought it was awesome.
Yeah. And even if she did give me a radio call, a TV radio call, KBOA.
That's kind of cool.
She apologized for that. I did want to say that I did get an email today. I was just talking to the other board members about this. I did get an email from, it came out, I think, through CQ Communications, which is CQ Magazine, and they're having a online virtual ham conference, and that's coming up in August. And now I can't find the email, of course. I signed up for it. I will put a link to that on it's called From QSO Today Virtual Ham Expo. It's August 8th and 9th. And they have keynote speakers, they have speaker tracks, they have individual exhibitor booths. And it's going to be available on demand for 30 days afterwards. So it's free, no charge. So what I'll do is I'll put a link for that on the website. So take a look at the front page of the website. You'll have a link to it. That is all I have for now. Thank you.
Well, thank you, Brian, for that. That's great. I didn't know about the online swap meet. That sounds really good. And all the vendors and stuff. That's great. Is there anything else from anybody? Wait a minute. There's only 4 of us, so there's nobody else to ask because we got a lot of people on the road, a lot of people busy. So the format tonight, everybody, I'm looking over here. Let's see, we got about 39 people watching, and we got the chat box there is chatting away. So if you want to say something, Jason's KM6FAK, he's been an awesome help with Ham Radio TV. He's going to help moderate tonight and help keep us on track and try to answer things on the chat box there. If we
did you want to touch on Field Day?
I'm getting there.
Okay,
there.
Good.
I was gonna say tonight, other than the little demonstration that we're gonna do here, when we open it up, we're gonna give people opportunity to talk about Field Day. Field Day was great this year. We had about 10 campers stay over. They came, and the 10 campers, by the way, that show up on late Friday afternoon. A lot of them show up earlier. They help set up the camp area. They help set up the kitchen. They help set up parking area. I mean, they help set up the multimedia, the welcome area. So all those folks came and did all that on Friday night. And then Saturday was a wonderful day. It was open to everybody on Friday, all Saturday night, and also into Sunday morning. So when Jason puts the link for Zoom on YouTube, click on it and join us, because at that point we'll have opportunity. If you have a question about what we talked about tonight, and tonight's topic is Ballons, and specifically one-to-one current Ballons to use with your dipole antenna. So we're going to get into that in just a little bit. Does that sound about right, Jason? Are that okay to go that way?
Yes, it does.
Thank you, sir. I check with the moderator. So I think we're gonna get right into the tech talk. Is that okay with everybody? Everybody on the chat gonna be okay with that? We're gonna get right into it. So tonight's talk is going to be about current Ballons, and the reason we decided to do it is because, quite frankly, we didn't have anything for tonight, so we made this up in the last 27 minutes. So with that said, I've actually been listening to quite a bit of chatter on our repeater and also the 2 Meter crew. They hang out over on 330, and there's a lot of new people, and they're putting together antennas, and there are a lot of people that have been in the ham radio for a long time, and they're building antennas. And I had something here I wanted to show you guys. Oh, here it is. So, and when building antennas, a real popular antenna is a dipole or a long wire antenna. And tonight we're going to specifically talk about the current Ballons and what they do for you. And I'm just going to hold this up real quick. You know, this is something that's been talked about. I've heard of several guys. This wire does nothing. It's a strain release for this test connector I have. But this is a 49-to-1 Ballon. This goes to the long wire. This side hooks to your coax. So we will not be talking about these. I didn't want to overlook it because I heard a lot of chatter about these things in the last couple of weeks. So tonight we're going to talk about what do I do when I build my antenna. And I've heard, and I'm going to just speak in real general terms, somebody heard, hey, maybe I should buy the Ballon. Maybe I should wind it at a coax, or maybe I should get a core and wrap some wire around it, or whatever. And there's all sorts of different opinions as to which one works better. And I want to start this off with saying, This is no reflection on anybody's system. If you put together a system using one of these devices and it's working great, that's absolutely beautiful. It doesn't mean you got to take it down and change it. If you want to experiment, that's great. What we're going to do tonight is just show you the different Ballons, very common ones that I hear a lot of people talking about. And we're going to use a device that looks like this, and we'll get into that later. And it's going to measure the common mode rejection of your Ballon. And really what we're talking about at this point is how much is that Ballon going to keep the RF from coming back down the wire on typically the shield of your coax. So there's been a lot of discussion about that, and we're not going to talk about really who was right, who was wrong, who's worked better, who's doesn't. All we're going to do is we're going to take a sample of 1, 2, 3, 4, 5, 6 different Ballons, and you're going to be able to see visually the difference between them and why you might choose to choose one over the other. And also, you'll be able to make a decision, an informed decision on your own. Do I want to buy one? Do I want to make one? Or maybe I don't even want to use one, which, by the way, if you want to test, you get a resonant dipole antenna, put it on a piece of end of a 50 ohm coax, and you go back to your radio and hook up your analyzer or your radio. You can adjust that antenna, and that thing is probably going to work great. I don't know what's coming back down the wire, but that works too. I've done it. I think pretty much every ham radio operator has. So let's get right into this. So we're going to start off with something called an ugly Ballon. You know, you all can comment online if you ever heard about an ugly Ballon. We're not talking about the person who made it. You know, I mean, that's obvious. Ugly technician, but we're talking about the ugly Ballon. So the ugly Ballon is typically this. So I made it out of RG8X, or typically called RG8 Mini. It's the medium sized. So I have a piece here that's about 6 feet long that's left over. And I just, you know, you often hear it. Hey, I took mine and I wound 8 to 10 turns around my coffee can, and I used some tape or some nylon, UV resistant nylon ties or whatever, and I made myself an ugly Ballon, and man, it works great, and it very well could. So the next question is, what is it doing for you? And so that's kind of what I wanted to know. What is it doing for us? So I wound it, but I used some non-conductive tape because I'm going to take mine apart. This is about a 25 foot, I guess, about 25 foot piece. I wound it around a cylinder. It was about the size of a coffee can, and I did it because it has really nice low loss BNCs on the end that we can use to test. So what are we testing? We are testing where I hook this to my antenna, and in this case, we're going to reference it to a dipole antenna, and we're going to assume that the dipole antenna for tonight's conversation is tuned properly and is resonant at the frequency you want it to. And in just a few minutes, you'll see that the frequency range that we're testing tonight is the entire HF amateur radio band. So we're going to assume whatever we hook to this in the real world is going to be resonant. That's a whole nother story. So that's there. And then this is wound in the ugly Ballon fashion or similar to it. And this would go to my transmitter. So we're going to start with the ugly Ballon. And what I would like to do is I'm going to switch over here. And here's the mess. This is the stuff on our makeshift test. We'll just be using the Ballon, and we'll be using this device right here. So what I'd like to do is help you understand real briefly what this device is doing. It's called a spectrum analyzer, and what you're seeing on the screen is, and let me see if I can, the frequency range, okay? And the frequency range, I'm actually going from, let's go up here, as you can see it. See, the start frequency is 1 megahertz, and the stop frequency is 30 megahertz. Okay, so this here is 1, and this line is 30, and everything else in between. And we can put a marker on here, and you can notice right here, the marker, it tells us what frequency we're on as I turn the dial. And we will be able to turn the dial and measure what our Ballons are doing for us or not doing for us within the HF amateur radio band. So to do this, I put together, this is a little test jig that I made. And this side here goes into the output, or the tracking generator output. This is the spectrum analyzer input. And what I typically do is I take all these connectors, and I want everybody to realize I know that it's not the abs. Look at that, the sun's coming in and messing up my screen. Jeez. That's not good. Anyways, I'll try and block it. So what we're doing is we're going to try to what's called normalize out or cancel out all this junk in the middle. So what we'll do, just for those who care, we'll push it in here, and we're going to go to the normalize, return it, and notice over here, it already says there's 0 dB. So, but we're going to turn it off, and then we're going to turn it on. Now we've renormalized it to where this is absolutely no loss. What's going in here is the unit is seeing absolutely no loss. So that gives us our reference point. Okay. So now we're going to disconnect. I'm going to reach around here and I'm going to disconnect that device. And now I'm going to reconnect. Take my little jumpers out. Okay. And now I'm going to connect my ugly Ballon. And believe me, my ugly Ballon is pretty ugly. I didn't put much effort into it. So we look at that and we say, what does that mean? Well, what I'm going to do is I'm going to try to hold this thing up in the air like this. Kind of keep it away from everything. And I just wound it just randomly, like you might do at home, and I'm going to try to hold it up here, and I'm going to put the camera back. Now, what is it doing? We're going to go over here to our marker, and let's go down here and look at at 80 meters. Let's go to the bottom of 80 meters, like 3.5. Are y'all able to read that marker where it says minus 12, about 3.55? Okay, so that looks pretty good. So what it's telling us is that frequency, I'm getting about 12 dB of rejection. So if I got some junk coming down my line, at that frequency, I have about 12 dB. So let's turn the marker up in frequency. Let's go to 40 meters, right around 7,200, okay? So right around 7,200, wow. I got about 23 dB, which that's not too shabby. I mean, that's very usable. This would be something that would be worth having if you couldn't do anything else, just wrap the coax up. But the trouble is, different coax behaves differently. Different number of turns acts differently. And the diameter would make it act differently as well. And as we go up in frequency, we're going to crank it up here to, let's go up to our 20 meter band. Right around there. There's 20 meters. So now we're about 3 dB down. We're around 17. And as you can see, the ugly Ballon gets worse and worse and worse and worse as we go up in frequency. So what does that tell us? It tells us that this particular Ballon works okay for common mode, and it's not very flat, and it's a little irregular because we really don't know what we've wound unless we check it. Okay, So that's something that if you just want to put something together and stick it up there, it would be better than 0. Okay? So that's the ugly Ballon. And by the way, guys and gals, we're only talking about the common mode, which is the RF energy coming back down this coax, because you don't want your coax to radiate. So what that means is the higher in negative numbers, the higher this number is, the better it is. Okay? So now let's move over towards, I bumped this. Let's move over here. Let's go to the next one. So this one is a not so ugly Ballon. It's nice and neat, and I put some connectors on it just to make it a little easier for me tonight. Soldered these on this afternoon instead of working. So this is not quite so ugly. It's wound on a piece of black ABS pipe, and I've heard people say, hey, get a wooden stick, a piece of non-conductive material, 2 or 3 inches. This happens to be 2. Wrap multiple turns around it. That usually takes care of it. And the number of windings, depending on who's talking about it, varies all over the map. So this one happens to be about 15. And I can't remember why I made it, but we did. And so we're going to put this in there. We're trying not to break the temporary connections. So now, whoa, look at that. So what does that tell you? If we use this one and we go over to our marker, which I'm going to do, and I bring it over here, I'm going to bring it down to the 80 meter band. What do y'all think that's going to do in 80 meters around the phone band, right about there? It's only about 3.8, 3.9. It might tickle 4 dB. That's not enough common mode. You want to, if there's anything left over coming back down that coax, you want to kill it. 3 dB is not that great. Now it is a kind of a linear response in a sense that as we go up, it's nice and smooth. And as we get to 40 meters, it's about 7 or 8. And as we get closer and closer and closer to 20 meters, and here we are. About 20 meters, it's got okay. It's like 13, because really what we're shooting for, remember, in negative numbers, the higher the better. So this is only 13. If it could be 26, it'd be awesome, but this one's not. And as you can see, as we continue through the amateur radio band, this particular one gets better and better. And now we're way up here in that's CB band, now we're in a ham band. It's about 20 dB. So it reaches the 20 dB mark, which is acceptable at the way high end of the band. But down here, I would say that it doesn't work so hot. So now we're going to switch over to another one. So this is the coil that you see where somebody just grabs some extra coax, wraps it around 8 or 9 or 10 or 12 times around the 2 or 3 inches, and this is what you get. The curve will look like that other one, but it'll vary in depth depending on how many windings and how wide they are. So that's our not so ugly Ballon. So then let's move on to the not so ugly Ballon, but a lot more windings, very, very tight on here. And what will this do? Well, let's find out. So we got to grab an adapter here. I'll try to keep this moving right along. And these are just examples. Situations with different people. And so here's this one. Now what I'm going to do is disconnect. Here you guys can see what I'm doing. I plugged it in here, and this one has wires on it. So what I'm going to do is I'm just going to take it and stick these wires in here and clamp them down a little bit. And these are binding posts. And those of you who know, this is only good up to about, 30 megahertz or something like that. Okay. Now I'm going to lift this up and hold it by this hook, which would emulate as best I can here in my makeshift lab, hanging from a dipole. Look at that response. As I move my test rig around, it will change. But notice right there, it's already at 20 out here in the ham band. It's already knocking on the door of 20. But as you get lower in frequency, we're going down here to they're only about 10 dB at 80 meters. But once we get past 80 meters, it behaves pretty good up here at 40. There's 15. It keeps going. And it gets down to above 20 dB right here in the middle of the band. So it's not a bad one. So for winding one out of coax, this one came close. And the only difference here is this one is more windings, and this connector in the bottom is connected to this SO239 connector, and then the wire just runs up here and the wire stops, and then the center conductor happens to be the red one, and this black one happens to be, and these eye hooks are just strain reliefs, and this is to hold it. So this is a decent. I actually used this Ballon on my station for about a year, and it actually performed pretty good, but it's doesn't have as deep of a notch for the common mode. It's not cutting the common mode energy as much as I'd like, and it was not as flat because I want to be able to use my dipole antenna or whatever antenna I've hooked it to that works at 50 ohms. I want my response across the band to be as flat as I can get it. So here's a little product. This happens to be an MFJ. It's a 918, MFJ 918. It is basically it is a commercially made Ballon, and we're just going to hook it up the same way, cram those big thick wires in there, and we'll take a look at that. Look at that. So this guy here, notice down here in the lower part of the band, it's 18, almost 19 dB. You get down here in the bottom part of it's quite usable. And keep in mind our test setup here, it's not perfect. It's for comparison purposes. We've done the best we can with what we have, but it's given us a pretty good comparison. So we look at it and go, wow, that's pretty flat, and it's working pretty good across the band. So I would say MFJ, put a little thought into that device. It's flat across the band. So you're going, okay, I'm on 40 meters, 20 meters, 15 meters. It kind of doesn't matter. It behaves virtually the same. And it starts getting a little bit less attenuation when you get to the bottom end of 80 meters, but it's still very usable. So this is a device that I would say, if you're just going to run out and buy one, something like this or this device would be a pretty good choice. And they're very cost effective. I think these are, somebody look it up for me, MFJ 918.
It's right behind you. Oh.
Well, I'm not looking behind me, Jason.
It's about $43.
$43. So this is a great, and it's 1500 watt, right? PEP. I have to look at the other screen. And
yep, 1500 watt.
Legal limit. And it says 1.8 to 30 megacycles. And guess what? They're right. It will work there. Now, when you get in the lower part of the band, they don't do the common mode check. But the balancing to balance your dipole So, and we'll do that some other time. I've checked this thing. When you hook your dipole antenna onto these two wires, and if I were to take and short out this wire, my impedance back to my radio is almost perfect. And I disconnect it and do it here, it's still almost perfect. So this thing does a really good job of going from balanced to unbalanced, and it does a pretty good job of the common mode, which stops the energy from coming back down your coax due to an imperfection in your antenna system. So not a bad deal for the money. So the next thing we're looking at, and we're getting close to being done with the demo part of this. I bet you guys are all just thank God. I have two more that I made. This one is a type 31 core, and there's 10 dual windings on this side and 10 dual windings on this side, and they're wound opposite each other, and they're connected in such a fashion so that energy going through here that's out of phase with this wire and this wire and this wire and this wire, it goes through virtually undetectable if they're out of phase. But if they're in phase, which is common mode, the energy trying to get back, it will knock it down substantially. So the question is if we spend the time to make something like this and put it in our own box, what does it do? Well, what does it do? That's what it does. Look at that. That thing is virtually flat from the bottom of the band, which is way down. Look at that, 28, 27. There's below 80 meters. There we are. There. It's 26, 27 dB at 3,700 on 80 meters. So you ask yourself, well, what does that mean? The other one was like 17 dB. Well, that's 10 dB more attenuation. 10 dB more of attenuation of a signal that you do not want. So what it means is that if I had a 100-watt transmitter and I lowered it 3 dB, I got 50 watts. But if I lower it 10 dB, I have 10 watts. So that's a big difference. So going from like 15 or 17 dB to, look at that, 27. And by the way, look how absolutely flat that is. I can put this anywhere on the ham band and it will work just beautiful. And that's what we want to see. Okay? We want to see it nice and flat. So this is something that you can build. And here at the club, we have a couple people that can show you how to build it. We got a couple club members that already did it. I think Frank and Bruce and Don. Somebody else has one too. And I have this one as well. This is something that's fun to make. It's made on this is a toroidal core, and it's the type 31, and it's the 240 size. And this wire is Teflon, or the PTFE. It's the real high temperature stuff. So this dude right here will easily handle legal limit on single sideband. And this would cost you, if it was built in a box that had the connectors on it and was designed to be suspended up in the air with your dipole, they'd charge a pretty good chunk of money for this. And we can talk about that later in the Zoom chat when you come on. Now, I have last but not least, I have this, which is kind of interesting. This one surprised me. So I'm going to plug my adapter back in so I can get this thing to work. What this is it's the same type 31 core as this, okay? But this is RG303 mil spec Teflon wire. It's actually PTFE. Look it up online, RG303. You do not have to use RG303. There's other numbers that are very similar. And if you buy this coax by the foot, I've seen it as low as a dollar, just under $2, and I've seen it as high as $4 a foot. This stuff is rated, it's over 500 watts at a gigahertz. They call this 3 gigahertz cable. It's made for jumpers and all sorts of cool things. I got these scraps at a swap meet, and you can buy it new on eBay, new old stock. It's all over the place. But there's other cables that have this very similar specs that will do the same thing. And we can talk more about that on the Zoom if you would like to. So what I'm trying to do as I'm setting this up here, I'll show you. What I'm trying to do is I'm trying to get my jig set up so that it interferes the least with the balance. So it's not like right on top of it or intermingling, but it's kind of hard. And I've purposely put this bench together. It's just a piece of wood. It's a non-conductive wood piece with no metal underneath it. So the closest metal is, so you notice I touched this metal. There's a little bit of stray capacitance in there, but we're not going to worry about that. So now, look at that. What does that number say? Right there, minus 30. And I'm up here. My cursor's telling me I'm right in the middle of the 11 meter band. Let's run it all the way down. Let's see what it is. That common mode is way down there at 30. Even 29, way 27, 28. Look at that. That's a pretty dang good Ballon. And it's pretty easy to make. I made that, what I showed you, this whole thing from this connector to that connector, I built it in about 15 minutes. I think it took me longer to go. No, I knew where this was at. So that's really good. Another thing, too, that's really good. Not only is this thing incredibly flat, these two devices, I'll put this one on the screen. These two here, I think if you, hey, Brian, I think you'll agree they tested the best. And it's the way they're made. And the third, number 3, was this guy, the commercially made one. And you got to get that out of the sunlight. So the MFJ. So, yeah, if you want to make your own, consider this type or this type. This type, it takes a little bit more time to build. And if you were to finesse these coils, right, or turns, and maybe add, I did 10 with the particular wire I used. If you want to monkey with it and finesse it, you could probably get this one to be a little better, because this guy here is potentially 30 plus dB down if you get the windings perfect. But what I'm happy about is, look at this. I mean, I am so close to 30 dB. I'm at 27, and as soon as we get up here, I mean, we're just hovering 30 dB all the way long. And that could be that could be because of how I wound them. So if you wind these a little differently, a little closer together, or even put one more turn. I did 10 turns. You might say, well, let's experiment. Let's do 11 turns and let's see what it does. Because what will happen with the more inductance, it might give you that extra dB and a half down here, to get that line perfectly flat. If you're into that, do that. So anyways, that's pretty much the overview of Ballons. And I hope I described the common mode as to why you don't want it. You put an antenna up in the air, your HF antenna, and you're feeding it with your coax. You want something there to where if there's an imbalance and it's causing the energy to come back down the outside of your coax braid. That's called common mode energy. It's coming back. So these coils here, or excuse me, chokes, they have what's called a high common mode rejection ratio, CMMR. So the higher the CMMR, the better off you are. And I've tested this one, and I've tested this guy here, and I can tell you they are pretty much dead flat on 50. I mean, when I look at this is a common mode curve, and we don't have time to change it over, but we do a completely different test, and we can set it up. We can see the impedance curve, impedance versus frequency. It's virtually flat. It's very, very good. And this guy here is actually really pretty good too. This is for the money. This is a particular one. I'm not promoting these guys. It just happened to test good. I'm sure there's others out there that I don't know about. But when you go to like this guy here, he's kind of okay, but it's not nearly what these guys are. Not even close. And then when you get back to our ugly Ballon, you saw the curve on the ugly Ballon, how it was all over the map. It wasn't nice and flat like this guy here. It's all over the map. Well, when you run your impedance curve on this, it's good, but it's not nearly as flat as this. And what I'm saying is when you put the Ballon in line, and if your antenna is 50 ohms, and what I do is I install literally a 50 ohm resistor right here, and then we run the test to sweep it on this side, and we start at 1.8 megahertz up to 1.8 megahertz up to 30 megahertz, and we look and see how is it affecting it, and what that kind of equates to is how much of an effect will it have on your SWR. And the less effect your Ballon has on that, and the flatter it is across the range for impedance, and the flatter it is, and the deeper the cut for common mode, the better it is. I heard something.
My bad. You're doing good.
Well, that's okay, man. Well, that's pretty much it. I think at this point, I'm going to stop babbling, and why don't you open it up, and we can chat about any questions. If I can answer them, I will. And if anybody wants to comment on their experience at Field Day, that's great too. So take it away, Jason.
Yeah, so right away I'll read some. I was putting Bruce up there behind us. Let me go back to this one. Okay, so let me read a few questions I saw in the chat. So okay. Richard in the chat says, why wouldn't you want anything other than a Teflon coax wrapped on a core, especially if you can't get? So they're talking about Teflon wrapped.
Why would you want anything other than that?
Yeah, I guess what is the advantage of Teflon? Let me reiterate that.
Super high temperature and much higher voltage. So when you're operating, and let's say you start operating an antenna that's out of resonance, you're trying to make this thing work, and you're using your tuner. You want this thing to handle the heat, high voltage in the heat. So this PTFE, I think it's called. Somebody look that up. Is it PTFE? Is a type, and I think it's Teflon's another term, but it's high temperature wire. Yes, you want it, and no, you wouldn't want to. Now, do people do it? Yes, they do wind stuff without high temperature wire. I did it as an experiment, and I used my 1500 watt legal limit amplifier, and I generated some really weird loads, and I took one of these, and I used I think I used solid core number 14 THHN electrical wire, and it literally arced through the insulation and started making weird noises. So I stopped.
Where do you like to get the wire? Where do you like to get that wire?
Well, this wire here, I actually got this at a swap meet, some remnant spools. You could go online and you can get the Teflon wire. Another thing you can do, and I appreciate the person asking the question, you can take the coils. Matter of fact, I have a sample.
Because, we need a good online source, Kevin, because with everything going on, I don't think we're going to see a swap for the rest of the year.
I know. We'll get it online. Well, tell you what, after tonight, I'll do some research and come up with some stuff. This is enameled wire, often called magnet wire. Magnet wire is made in different levels of insulation. You can get the high voltage rating magnet wire, and there's places on Amazon that sell it. And if you get just standard off the shelf stuff like what's right here, that's what this is, standard off the shelf. It's not high voltage wiring. And this particular transformer, I've tested it. It's only good up to about 350 watts anyways. And if I went past 350, and if I had any kind of a mismatch and I just kept running it, it's going to get hot and it might arc, because the voltage that's because this is a 49-to-1. The voltage on this side is like way higher than this side. So something might arc. I didn't do it to this one. So to answer the person's question, you want high voltage wire.
Awesome.
Teflon, I like it because it's flexible. It's stranded. It's easy to solder, and I like that. Now, what's cool about this is it holds its form, and a lot of guys, they'll get the non-conductive fiber tape and they'll wrap their core in it, and then they'll put the wires so you don't damage the wire as you're wrapping it around the core.
All right. I've often heard guys will test their Ballon by running as much power as they can and on FT8, because that won't let up, and that's full boogie.
Right, yeah. And this stuff here is Teflon too. Matter of fact, I think if you look up RG303, I think one part of it is actually called PTFE, I think, and the other part is an actual, I think the dielectric is some kind of a Teflon. I mean, this stuff is just like super high temperature. Matter of fact, I don't know if you could see it. Let me see if you can see it. Is that halfway in focused?
Ish.
Ish.
You're shaking it. Stop shaking it.
Okay. Can you see the end of that where the white part turns to wire?
Okay, yeah. The insulation.
Okay. The insulation, I'll try to point to it.
Right
there.
Uh-huh.
That is Teflon, and when I put my 800 degree soldering iron right next to it, didn't phase it at all.
Ah, that's a good test.
It. But if you put your 800 degree tip and you're not careful on non-Teflon wire, might be hard to see right there. That wire, it shrunk back about 1/8 of an inch because I held it on there too long.
Oh.
So the short answer is you want to use high temperature wire, and you shouldn't. You shouldn't. If you're operating over a couple hundred watts, you're asking for trouble.
Now, a good question, never a dumb one. Where do we install these Ballons? Do we want it right against the antenna, or should we have one at the radio, or could we have two at both places?
This Ballon is designed to operate at the feed point of the antenna. So if this device here were built correctly, it would be inside of typically a square box. Often they're gray or white, and there would be a.
Bruce is helping us out. Bruce is showing us behind you.
Yeah. That's a picture of a dipole.
So you want to put it right up there.
And this, we would have it in a box so that you could hang your dipole off this and hook the dipole wires for strain relief. So what I kind of did you guys a little bit of an injustice tonight by, this is the raw component that would go inside a non-conductive box that you would put a connector for your coax here. These wires would come out and be connected to your actual dipole, and there would be stainless steel eye hooks to loop your dipole ends through to use as a strain relief. And I think what I'd like to do before the end of the summer is we'll like to go out in the field and we will build a dipole antenna with a completed one of these from scratch to show people how to do it, and maybe we'll document. You've seen this now, so we'll document how this goes into a box too, because I'm going to put this in a box so it can actually be used. Although I got to keep one for demos because we'll have to do this again next year for all the new hams.
Yeah, absolutely. And that video I was showing earlier is a previous video we did at the club where we took some measurements with just an MFJ analyzer, and then Bruce went on about kind of what he did and how he drew it. And you know what? I'm trying to show it. There it is. Now, Kevin, a few people were just kind of curious, what is that device that you're using to measure it? Because I think we're all very much into how good that looks and how well that works.
The device I'm using at the moment is a Siglent 3021X. It's a spectrum analyzer. It goes from, I don't remember, like 100 kilohertz to 2.1 gigahertz, and it measures frequency versus amplitude, and I can set it up to do a bunch of different measurements. For what we did tonight, basically I set it up so that I put in, I'll try to explain it. Oops, that's not right. These boxes are, it has a BNC connector which goes to the input of the device, okay? And then inside this box, there's just two little resistors that are isolated from here, and two little resistors that go from the center conductor to both of these. And then the same thing on this. And when we put our test unit in, what we're doing is we're literally sending the signal from the output of the unit to the input of the unit, and we're telling the unit when we normalize it, look at that, I'm able to almost get it flat. See, I got 1.5 dB of loss with no connector because I got it so close. So anyways, we'll tell the machine when we put the coupler in, like right here. So now I'm varying between 0 and 0.03 dB because, like I told you, these aren't perfect. So now the analyzer says whatever goes in comes out.
Show us your screen.
There's zero. Thank you. There's zero loss. Okay. There is no loss. And you can look at the top and you can see the reference is 0 dBm. That means whatever goes in goes out. I'm not taking away anything. So, and I set the frequency range. I showed you that earlier. I set the frequency range. You can see here where it says start of 1 megahertz, and I put stop 30 megahertz. I did that specifically because I wanted the ham band. So now what I'm going to do is I'm going to just take off my this guy here. Let's see if you can see it, which is just a barrel connector. It is nothing special. I didn't test it or anything. I'm going to reinsert, and I'll put this so you can see it. I'm going to reinsert the Ballon back into my little jig, okay? So now all I've done is put this device. It's called the DUT, Device Under Test, okay? So now when I go back to the screen, what do we see? Across the band, it's showing us what our attenuation at a particular frequency is. And as we roll and I'm touching my jig, so I put my arm right on the connector. So as we go across, look at the marker frequency. There's 80 meters. I'm 27 dB down. That's pretty dang good for a throw together homebrew. I made it for nothing. Now I'm up here in 40 meters, 7. So those of you who just got your general license, you should know that your general is 71 and I don't have the resolution here very tight. Should be 71, 75. I can't even get that. Well, here's 7148, and you get to talk up to 7,300. But look how flat it is. It's almost perfect. And as you continue through the band, and I come right up here to the good old, look at that. I'm like over 30 dB at 20 meters. So the machine is a spectrum analyzer that measures frequency versus amplitude. It's kind of the opposite of an oscilloscope. Well, oscilloscope measures amplitude versus time. We can talk about that later. But I forgot to bring it out here. I forgot to bring it out here. There is a device called a Nano Vna. A Nano Vna costs about the one I would recommend is about $80. It comes in a case, has its own little jumpers. The thing is awesome. It will do this. It's got a screen that's about that big, and it has some apps to hook to your phone and so on. I have one, and for the money, it's unbelievable what this thing does. So if you want to learn about how a spectrum analyzer works and how to do these type of measurements on a very cost-effective way, buy the Nano Vna and learn how to use it, because it's a 2-port device. It has an S11 and an S12. We can do a video on that later. And and you get one of those little, what do they call them? Those little touch pins for doing your phone, your BlackBerry and whatnot. They're capacitive pins. You touch it. Get one of those guys. And because my big finger just doesn't work that well on it. I saw another fella on YouTube. He was using a guitar pick, and it was working great. It worked really good. The tip on a guitar pick. So if you have the Nano Vna, experiment with it, okay? If you have one and you don't know what to do with it, let us know, and we'll try to have a workshop, and we can set up some of this, because it's too much to talk about tonight. But it's a spectrum analyzer. It's made by Siglent. Another company makes one very similar to it. It's called a Rigel, and real spectrum. And by the way, this is as close to a real spectrum analyzer as I'm going to get without spending a lot of money. And I have a very old real one that's on the other side of the lab that when I get everything organized, I'll be able to use that one. But this dude is just so convenient. And by the way, the Nano Vna is a really good tool for folks that want to do that. So anyways, I think I rambled on about that way too long.
All right. So yeah, one last question, and then
Sure.
We'll wrap up the meeting and then see if anybody wants to come join us. But someone asked, was pretty good. What are your thoughts between the ferrite beads versus your donuts, your toroids?
I wish I would have done that for you, because I have a big stack of ferrite beads. First of all, the clamp-on ferrite beads, if you want them to be for RFI or common mode rejection, you need to get the type 31s, and they need to be made for that. Because, and we'll use this device later, not tonight, and I'll show you how you get a handful of, and I think I had one laying right here. Use an example. You know the ones, the ferrite beads that are around your VGA connector or on your computer, and you've got other stuff that goes in. Well, often you'll find those type of clamp-ons for cheap, but you don't know what they are. And you clamp them onto your stuff, and you're like, man, I still got RFI, and I still got the problems. Well, that's because they're attenuating the wrong frequency. They're not attenuating what you want it to attenuate. So to answer his question, yes, you can use clamp-on beads. I had a friend of mine. He had a Ballon. It was about this long, and it was about half the diameter. And inside it was a piece of RG. I think it was 213, but I don't know for sure. And the company stacked really nice ferrite beads in a row, a bunch of them. And then I think they heat shrinked over it and they put it in a tube and they put a nice connector on the bottom and they did something similar to this on top. It worked great. It worked great. Now, I did not measure the common mode on that one. I didn't do it.
Well, that'll have to be another video. It seems like this is fairly popular. Actually, hit that like button, guys, if you're enjoying this and want to see more from Kevin, because I'm trying to get Kevin to take his show on the road. He's got a lot of stuff up there in that noggin of his. But behind you, actually, I took you off the screen right now, Kevin. I recently found this website, and I just posted a link there at 8:01. But if you have these round cable snappets, as it calls it, they have a variation of sizes and shapes. And if you have one that doesn't meet the criteria, I apologize. But the idea is you can go down through here and take some measurements. With some kind of caliper, I'm going to recommend. A tape measure probably won't cut it, because this stuff is very much dialed in precisely, and then it'll come over here and it'll tell you what kind of impedance are you dealing with. So if you have a handful, you can sit down, you go through them and figure out, well, what do I have here? So that's definitely pretty helpful.
I'm grabbing something.
We lost Kevin. Oh gosh. Now I guess I'll have to say something entertaining. But yeah, that's having the right coax, the right length, and the right common mode rejection is huge as far as how much power do you want off that antenna, and then how much of that RF do you want back in your shack. And you might not even know you have an issue. Maybe nothing weird is happening in your shack, nothing is biting you, but maybe you're not heard. So there's a lot of reasons to kind of go down this road. But again, anything will work, right? I hear a lot of guys, who cares how long the coax is or this or that. I get out, I transmit. Hey, that's great. This is kind of best practice if you really want to get down to the nuts and bolts and really understand what you're trying to achieve and how to get there. Ultimately, we get licensed. We start operating. I mean, heck, I'm only a few years into this hobby, and thank goodness Kevin lives just the city next door to me to really break everything down and explain it. And really, I'd like to think I'm getting the most out of what I got, and I'm not over here with a whole lot of expensive gear, but between the coax, the Ballon, and the antenna, you can do some damage.
I'm putting together a really funky, bad example that I hope works, because this will give you a really good example of what to do and what not to do with this stuff, because I happen to have a core here. We know this core works because we just tested it. Well, let's do this. I'm literally taking a clip lead with an alligator clip on each end, and I just wound, just for fun, I wound 1, 2, 3, 4, 5, 6, 7 windings. I just loosely wound them, and it's still set up to where this guy will still measure. Oh, there we go. Okay, so there's what it looks like when I just randomly wound some wire around a Type 31 core, and at I got 19 dB of rejection at 12 megahertz, and I just I got lucky. Look at that, I got 20 dB, 22, but remember, when I hook this up correctly, I get almost 30 dB, right? So let's do this. This is a core. I got it out of a power supply. So let's see. And I'm doing this live. I have not done this particular core like this on my own to know that it's going to work one way or the other. But we're going to make kind of an assumption here. This core came out of a switching power supply. So the switching power supply is obviously operating at a pretty high frequency. I don't know what, but it was probably pretty high frequency. So this core is not a Type 31. I don't know what it is, but I got it for free. I pulled the high voltage enameled wire off of it, and I used it on my RF stuff because I wanted some free wire. And then I got really excited. Let's see, you got 1, 2, 3, 4, 5, 6, 7. Same. So I'm going to put it down here, and so I did wind this core one time, very similar to this one. Didn't work so good. So here we go. There's a known core. It's type 31, and let's just move the cursor out where we can see it. Okay, we're at -20 at 9.6. We're not going to touch it. Okay. So let's just unhook this, and they're the same type of clip lead wire, and they're both 7 turns. It's just random. Let's just see what happens. What happened? Same wire, same test. Look at what I got. I got 14 dB, or excuse me, I got 4 dB at the same exact frequency. What does that tell us? It tells us that core is the wrong kind of material for what we're doing. So what if we did this? What if we went to our frequency and we went to our stop frequency, and let's make it 200 megahertz. Oh, gee, look at that. It's for high frequency. So if I were to take my marker, and notice I just did it so random, and the higher the frequency goes, the more the proximity effect of my body. So now, look at that. I'm at 100 megs. I'm at 17. Wow. And over here, so I'm about 20 dB. So if I wound it correctly and was using it at the correct frequency, it would be awesome. So now let's undo this random wire deal, and let's hook up this type 31. It's got the same random look. Look at that. This one kind of sucks at the higher frequencies because it's the wrong material. So we go back to the stop frequency, and we'll put it back down to the ham band. And look at that. Down there at the lower end of the ham band, it's working pretty well. And if I were to take these, if I were to monkey with this and I make it tighter, see, it actually gets, see, it starts getting better. The more symmetrical and the better the windings are positioned between each other, it just works better. That's just an absolute mess. But it proved a point. It proved that this core is for much higher frequencies than this core. And that applies to those snap-on ones too. Some of those snap-on ones are made to keep that high frequency energy from getting out of your stuff and messing with your TV, messing with your 2-meter radio, your UHF radio, all that stuff. So some of that stuff is real high frequency. So the type of material matters. I think it's, I want to say DX, is it DX Engineering or is it no, or Palomar, one of those two. I'll look it up for you guys. Guy has a great chart and he sells all these parts. Okay, so he's got the stuff that other people don't because he's really a good guy. He's an engineer, and I will get his information for you so you can learn about it. So there you go. Any more questions, Jason? Because I'm not looking at the screen.
Yeah. So let's see. No, I think that about sums it up. Let me bring the rest of the band in here.
Yeah, they can ask questions. We can go live and if ask me questions and I'll just make stuff up. Yeah.
So the Bryans and the Doug, do you guys have anything to offer or share or comment on? We are we'll wrap up the club meeting here in a little bit, and then we'll leave it open for anyone that wants to join us in Zoom, like I said earlier.
I will say quickly that if any of our members has any topics that they'd like to hear, they can send them to either myself or Kevin, and we'll
send
do our
them
best.
to Doug. If you want something done, send it to Doug. Really.
Okay, so send me the topics you want, and we're always looking for topics to try to stump Kevin.
And Doug, are you good on QRZ? What's the best way to find you? I guess you're speaking to club members right now, so.
That's a good question. Let me get my QRZ a little more user friendly.
Okay. All right. Well, for people out in YouTube land, I'll just field the comments.
Well, just so you know, there's a lot of very smart people in our club, so it's pretty easy to stump me. This stuff here, I just happen to really like it, so I play with it. But there's going to be stuff that I don't know about, and there's people in our club that do. So give us your suggestions, and we'll absolutely we will make an effort to get somebody that's proficient at that topic and try to present for you, or bring somebody in who is. I'm actually looking at a couple of guests that are just fabulous speakers. If we can get them to Zoom in, that would be awesome.
Zoom. All right. So then, do we want to bring the meeting to adjourn?
Yeah, let's bring the meeting to a formal close, and then formally open up the Zoom to anybody who wants to hang out for a while.
Okay, very good. I'll drop that link. And the wife came out. She said, "Do you want a plate of food?" Wow, I must have cleaned the house or something today. I don't remember.
My wife offered to bring me food out here tonight. And I said, sweetie, I love you for that.
How's that going to work?
It's bad enough they have to watch me. They shouldn't have to watch me eat too. Yeah.
All right, guys. Doing the old copy paste. Feel free to jump in, pick Kevin's brain. And another thing too, a lot of this, quite a bit of what was covered tonight has happened at some meetings, various coax lengths, speaking about power, efficiency. So go check out the the back library of Ham Radio TV, and you might find something that you didn't know is there. And Kevin does a lot of great presentations and demos. So there is our link for Zoom. Hop on in, tug on Kevin's ears, because I will tell you, Kevin is really good at talking in person or like this, but as far as email and some of that digital stuff, he's not the greatest. Although, maybe he'll shift into retirement stage in the next handful of years, or maybe, I heard Walmart is really getting popular with the grocery deliveries. So, then he could probably answer emails.
Yep. Mm-hmm.
People are saying thank you. Absolutely, yeah. All right, I'm getting the buzzer here. We got Carlos, we got Doug jumping in. Yeah, and this is something that when I joined the club back in 2016, and I started showing up, and Kevin and a few other people were doing these presentations, that's what led me to starting to bring a camera, and everybody was okay with me bringing a camera. And I realized that not everyone has, a Bruce, a Kevin, Brian. Both Brians in this have shared great presentations, and many more that I can't think of right now about their experience. And it looks like we got some members jumping in. I need to change the alert setting on my computer. I know it keeps popping up. 74 Celsius.
Visitors are welcome too. We guys, if you're not a club, we've had a few misunderstandings, and just with our communication is that you do not have to be a club member to come to our meetings, and when we open up the Zoom, you do not have to be a club member when the Zoom is opened up. It's for everybody who would like to join and visit.
Absolutely. And one day, if we have we meet, if you're not familiar, we're here in Northern California, and we meet at a local, would you call it a city or municipality airport, at the Nut Tree, and they don't really have a great internet speed for us to utilize and go live. Otherwise, we'd probably be doing some live stuff from there. And don't forget, as you join us in Zoom, to mute any kind of YouTube feed.
You mean like
here
that one?
here I come. 5 seconds.
Here I come. 5 seconds.
All right. Hey, Mr. ADD, that's you, buddy. We love you, but I muted you. Okay, thumbs up. I said I muted him, and then he spoke. I love the guys in the club here. And by the way, Doug brought his, what is that vehicle called? The EM50. Let me, I can pull from Stripes, the ultimate combat vehicle. Doug pulled that into our field day. It's a fantastic RV.
The actual GMC factory motorhome, 27 feet long.
Give us more audio, Brian.
Audio.
There we go. How's that?
Ooh, I like it there.
All right. So that is the GMC factory motorhome, 27 feet long. And yes, it was definitely featured in the movie Stripes. I actually used to have one. Mine was the Baja, which was a boring beige color.
Mine is banana color.
Yeah, because you've gone bananas.
That is a great, yeah. And the other color in the movie was green, wasn't it?
Yes, that is correct. And in fact, 1, 2, 3, 4 houses down from me is actually a green one.
We have another N6 VLF. That's interesting. Wonder how that happened. Oh, maybe it's the, I need to drop that off of there. That was the password, so.
Oh, okay. That's all right.
So let me open the floor. Would anyone like to ask Kevin or anybody questions? I'll monitor chat at the same time. Corey and Richard and Justin, I'll thank you very much. There, Kevin.
While we're waiting, I want to touch on something. I just kind of did some piddling around on the interwebs. And Rigol actually has a entry-level one for us ham radio types because it's relatively inexpensive. It goes all the way up to 500 megahertz. Brand new. I'm on DigiKey's website, retailing for 700. And that goes from 100K to 500, which would cover the majority of ham radio operators.
Oh, yeah. Is that a PC-based device or is it a standalone?
No, it's the standalone unit. It has USB and a network connection on the back of it.
That's cool. There's some PC-based devices out there. Actually, I one of these days I'm gonna get. There's a cool one I want. I don't have the room for it right now. But I like the PC-based ones because it's super easy to put those up. Like I could have put that screen. I could have shared the screen. It would have been easy instead of having to have a third camera. Kind of sucked. But anyways, that's really cool. Rigol makes nice stuff too.
Yep.
So if Rigol's making it, Signalant's right on the heels.
Yep.
Well, they may already have it. I don't know.
I didn't see anything, but the unit that you have is currently retailing officially at their MSRP of $13.95.
Yeah, that's without the RF. Well, maybe they're giving it away. I hope they are. Wow, somebody's breathing in their microphone a lot. That's without the RF. There's an RF supplement. They charge like $300 for the software package, which is, I think, is a lot.
Yeah.
But anyways, you don't actually have to have that. It works great without it. We didn't use any of that junk tonight. This thing does what $10,000 machines do, and some of them don't do. It's just a little bit, it's a consumer-based thing, but man, it is so cool. It is so cool. I mean, I got my real HP over there. I actually have two of them, and this is not a service monitor, by the way. I need to make that clear. It's not a service monitor. Do not buy one and connect your radio to it. By the way, do not connect your radio to your Nano Vna. You will blow it up. There is a way to do it, and we'll go over that. But it's like we got basic, entry level, and then you probably should be a little above entry levels before you hook your radio to your Nano Vna, because it'll blow up if you're not really careful. Just letting you know.
Yep, gotta have that magic box.
Yes, you need it. You need it.
Question. This is Doug.
Go ahead.
So I've got a Nano Vna, and I've got two long wire antennas, and one of them apparently has a break in it. Is there some way I can tell how far up the wire that break is?
Yep. The Nano Vna has a default. I can't even say the word, but detection default. What it'll do is it'll give you a line, and that line there'll be a blip, and it'll keep going. It'll show you the connection, and then if there's an actual break in it, you'll see a big old spike. So the answer is yes. It does have a distant to fault capability. Yep. And don't you have a? Well, I don't know. If anybody bought the not the Zoom, but the I'm losing my mind. Rig Expert, the Rig Expert. They make one called Zoom, but Rig Expert, they also have a handheld unit, and it will also do distant default. And some of the MFJs, if you look in, this one might be too old, but some of the newer versions of the 259, 69, they also do distance default. So yeah, there's a lot of them do it.
Where do I go to find instructions on that?
Oh, well, the first thing I'm going to tell you to do is go to on YouTube, and you guys can write this down. I've watched a gentleman. His name is Alan Wolke. His ham radio call is W2AEW. Alan E. Wolke, W2AEW. Go to YouTube, just type in W2AEW. Go to his videos, and just recently he did a 4-part tutorial, about 4 to 7 minutes each, give or take, on the Nano Vna, and one of them specifically addresses to a fault to distance, and he also shows how to do the couple of other things. And guys, watch that. I'm going to be really honest with you. I own one, and it's really cool. I don't use it that much, so I got to learn some of its little things. Like this guy here. I mean, I got like buttons. You know, I come over here and I just push the button, and I do what I want it to. It just does it. The Nano Vna will do virtually the same thing, but you got to get your little guitar pick or whatever and work your way through the menu. It actually does up to 4 traces, and it also does has a Smith chart built into it too. It's pretty dang cool for that $79, man. It's unbelievable. So we'll play with it. That's something we ought to get together in person, maybe. Invite people that have it over, lay them out, and we can look at them into the dummy load, look at them into a couple different antennas, and you can characterize. Matter of fact, if you go on YouTube, there's a bunch of guys. They were characterizing their HT antennas, and were like surprised how crappy some of them were and how good some of them were. It was pretty interesting. Very interesting.
Thank you very much.
You're welcome.
Fred, it's great to see you right side up.
Yeah, I'm driving, man.
Well, that's concerning even further.
We're always talking to Fred while he's commuting somewhere, man.
I pick up my son.
Yeah.
I'm almost home.
Okay. Man.
Hey, my Nano Vna came with a guitar pick.
Oh, it came with it?
Yeah.
Yeah, I didn't know they were giving them with mine. Mine didn't. I got mine almost 6 or 8 months ago, and I started seeing guys using guitar picks. I'm like, that's pretty smart. That's pretty cool. I mean, I was using a giant chisel. I don't. Anyways.
A tweaker. We call those little tweaker screwdrivers.
Tweakers, yeah. Yeah.
Plastic. We like it. The plastic ones are best.
Mm-hmm. Oh, yeah. Let's see here. I have something here. Don't everybody talk at once.
I have a question.
Go
Yes.
ahead.
It's David.
Hey, Dave.
Kevin, I've got a Gap Titan DX multi-band vertical antenna, but the 40 meter is a wound copper wire, arranged in a square around the thing.
Mm-hmm.
Now I don't have any Ballon, but I've got this thing attached to about 100-foot low loss coax. And I have a huge noise problem. Maybe everybody on the planet does right now.
Yeah.
But I did buy from Palomar a specific set of those clamp-ons for my ICOM 7300.
Right.
Do you think that I should? I mean, how do you deal with a multi-band vertical antenna that has a wire for 40 meters, which is what I'm on most of the time?
Well, what now? Then is there noise in your receiver?
I get like a standard S7 to 9 noise level.
Oh, okay. See that the current Ballon and the Ballons, none of that's going to really help that.
Yeah.
That's all about keeping the RF out of your shack and matching the cable to the end, all that stuff. But when you just turn your radio on and it goes, you look down there and you go, man, it's S9. Heck, at my house, a couple of times I've had S9 plus 5 of just junk, and then some nights it's just gone. And I've actually turned everything off at my house. I haven't done it recently, but I thought for sure I had an LED light or something. I'm gonna do it again. But recently it's been on 80 meters it's the worst usually. But the thing is the signals, holy cow. I mean, some of the 80 meter signals lately have been so loud it didn't matter anyways.
Yeah, my signal's getting out fine from what I can tell. It's receiving that's my problem.
Right. Because unfortunately, what'll happen is your vertical antenna, it probably has a pretty good low angle takeoff angle, so you're getting out. The thing about it is, if it's sitting on the ground or low, is it low to the ground?
It's 12 feet off the ground. The base of it is 12 feet off the ground.
So, and are you surrounded by buildings and trees and?
Oh yeah.
So that's part of it. Your receive antenna is just low.
Yeah.
So you may have a little more of a problem receiving, and somebody might be hearing you great, and you might have a little bit of higher noise floor, and you're just not getting enough receive energy to hear them.
Yeah. It's particularly bad during the day, but at night it's a little bit better.
Yeah. If you have the space, and people don't always do, you like 40 meters, if you could get a test dipole up and just try it. And by the way, we just had this conversation with another ham. I had a friend of mine who lived down in Temecula, California.
Mm-hmm.
And there's a lake there in Temecula. I forgot what it's called. Anyways, nice place. Every HOA like on steroids. So what does he do? He wants an 80 meter and a 40 meter antenna. He goes up on his chimney and puts like something not much bigger than a broomstick and paints it where it blends in. And then he puts, as a matter of fact, the Ballon I described earlier with the chokes inside, the ferrite beads, that was the one he had because it was nice and long and straight. So he literally taped it or now untied it to the stick. He ran magnet wire. You couldn't even see it from the top of his house. It was like number 22 or something. And he ran that down to the flower bed in the front of his house. And he put a stick, which was looked like one of the sticks from one of the trees or the flower, hooked the end of his 80 meter antenna to that. Dude ran a KW into that all the time. Wow. And I talked to this guy, and he had lived in an HOA, and he actually saw a couple of birds hit his antenna wire because they didn't see it. It was that stealthy. So if you have an opportunity to stick up, get the coax up there and put some magnet wire in a HOA type situation, or you don't want your neighbors to know, a resonant antenna with a right length of coax and 400, 500, 600 watts will work fine on that thin wire.
Okay.
Unbelievable.
It's a good idea. Good idea. Thanks.
Just an experiment. And it's cheap. Very cheap.
By the way, this was extremely informative for me on the Ballons tonight.
Oh, well, thank you. I was 15 minutes before we were supposed to start. I was trying to come up with something.
Yeah, he only called me yesterday evening. What should we talk about?
That's the way you should do it then. That works good.
Actually, I came up, actually it was Jason an idea. And then this Ballon didn't exist until this afternoon. And then, and I got to thinking, man, I got to make one of those expensive ones. So I grabbed another core and I made this guy. This guy just, I got to do some more testing. It's really works better than I thought it would. I'm going to do some more testing later because, man, I looked it up on the internet. I've seen this type of balance selling for $90.
Wow.
Inside, yeah.
You know, Justin brought up a great idea too. If we wanted to all go in on a larger spool of that fancy wire, what did you call that? 303?
Oh yeah, you don't have to get 303 though. We could use the cheaper stuff. 303 is this insane mil spec.
Got to be mil spec.
It's crazy gigahertz. The stuff that's there's another stuff that's cheaper. They'll do the same thing. Because we only care about up to 30 megahertz, and we're not going to put more than 1,500 watts, right? So
you mean 313?
It could be. I don't have the numbers memorized, Brian.
I'm sorry, 316.
Yeah. Oh, 316 is super thin. No, you want to stay. You want to stay with the high temperature Teflon PTFE stuff. And this has a silver, all this series has a silver plated shield. So it's really, really nice. And the center conductor. So, I mean, I wound this thing and was like, holy cow, that thing is great. And plus, if you want to, so you want to make a 5,000 water or 3,000, I have no way of measuring it because I got nothing that puts out that much power. You just double stack the cores and use more wire and it'll handle more power.
Yeah, but actually, the 316 is PTFE insulation, silver-plated copper, and silver-plated copper double braiding.
Yeah, and that's cheaper than this stuff, right?
Yeah, I just bought 10 meters of it for, I don't know. I think it was like $12 or something.
That's pretty cheap. No, 316, that's not that ultra mini stuff, is it?
$14.98.
Where did you buy it from?
No. I'm being cautious here. 316 sounds like the ultra mini stuff that fits the SMA connectors. Check the power handling on it, because the stuff we're talking about will handle like 1,000 watts at a gigahertz or some ridiculous amount of energy.
Yeah. Okay.
Just make sure. But this is cheap, and then. The swap meet thing is kind of done. So I happen to have several pieces of it, but we can get it. It's not expensive. Not expensive. If you happen to have an airplane laying around, take it apart, just cut it out. They use it in those in airplanes, I think.
Is there a gauge of wire you should look for particular?
For this?
Yeah. Or no, for the other one.
Oh, the other one? Oh, I use on this one, I typically use 16 or 18. Now, there are guys that use 14, but 14's thick, man. This is 18 gauge wire. And 18, this stuff right here, this thing will handle your legal limit, no problem. No problem.
Does the diameter change the way it reacts at all either?
I have not noticed that. I've noticed that it takes... The thicker wire will handle more power, obviously, but the problem is a thicker wire you want to use. It's harder to deal with because Here, let me see if I can show you. You see if it was thicker wire, it would take up more space.
Kevin, go back to the mic.
Oh, you mean that? So it takes up more space with the thicker wire and the insulation. That's why some guys they'll use the magnet wire. They'll get the magnet wire. It's like 14 gauge or something, and then they'll put that tape on here, and they'll also get this sleeve. It's a really, really thin sleeve, but man, that's a lot of trouble to go to. I mean, I've never had an amp that will go past 1500 watts anyways on sideband. And that's another thing too. If you're operating on sideband, those are, that's energy that fluctuates. It's peak. So I put my infrared thermometer on this guy, and I put it on as close as I could get it to legal limit. It was over 1,000 watts. We yacked and yacked and yacked and yacked, and I measured it and went, it was like didn't even get warm. But then again, I'm operating on I used a decent wire, and I'm operating an antenna that was resonant. So there was little or no energy loss. There was really nothing much for it to dissipate. The thing about it is when you get an antenna that's out of whack, and you get high voltages and crazy reactance and current and stuff happening, and this thing's doing its job, that's when it's going to generate heat. Just like this guy here, who's the actual 49-to-1 transformer. When I put a long wire on here for 80 meters, and I put it on my amplifier, and I'm sitting in there and I'm talking and I'm tuning up, and I put 400, 500, 600, 700. I'm like, wow, this is great. So then I noticed on my watt meter, I go, wait a minute, my SWR changed just a little bit. So I grabbed my, it was right outside my window. So I grabbed my infrared gun, shot it over there, and went, whoa, it was getting hot because I was overdriving it. So the guys that were telling us on these, if you want to use legal limit, you got to use it at least 2, probably 3 cores to handle the heat. And they're right. They're right. So these you can get away with. This is, I mean, man, you could probably run and no hate mail from anybody, please, out there in YouTube land. I have not measured the how much power I can put through this, except I have operated sideband between 1,000 and the legal limit for extended periods of time on a resident antenna on a half wavelength piece of coax. Doesn't even get warm. And then I detuned it a little bit and used my tuner at the radio, and I operated on a frequency that wasn't perfectly resonant, and it was no appreciable difference in heat. I have not operated 1,000 watt CW on this, but I would. I think it would handle it. So if you're a big high power guy or gal, and you think you're gonna like really go big, buy the big giant amp, and you're gonna push the legal limit, use 2 cores. You just use 2.
Kevin, when you say use 2 cores, do you mean put the 2 cores together and then put wire around both of them?
Yes, you stack them.
Yeah, not 2 separate wired cores.
Correct. Not in parallel or series, but stack the actual core.
Yeah,
like a sandwich.
Yeah, like a sandwich. You glue them together with crazy glue, and you sandwich them.
And then you wrap the wire around them, right?
Then you wrap the wire around.
Okay.
Them. Yep. There's a and this version here, I mean, I have this exact one on my tower, and I've been using it now for about 2 years, and I'm pretty sure Bruce has the same one or close to it. And I know Don has one. And Don, I mean, if he can, I mean, he likes to run, he runs 1499 all the time. You know, if he can run 1499 watts, he will. So this dude works. But I didn't invent this. This has been around for a long, long time. And the cleaner you do it, the more symmetrical it is. Use really good wire. It just behaves even better. But this dude here, man, this is a 2,000 watt deal right here. I mean, I can't imagine any of my equipment ever heating this thing up. I guess I could if I see. That's the thing too. If you're building, I did mention this earlier, but if you're running a coax out there and you're going through your 1-to-1 current Ballon, and you're running a 80-meter antenna, and then you like try to make this thing operate on 40 and 20, and you're using your tuner because your tuner will match it. Remember this: your tuner matches the mismatch between what's going on outside and the 50 ohm input on your radio. So I don't know what's going on that mismatched antenna, but that tuner has a capability of getting rid of it and matching it to the radio. So the radio and the amp is happy. On the other side of that tuner, you can have crazy high voltages and just stuff going on that isn't that great. And if you're trying to get a non-resonant antenna to behave, and you tune all those inconsistencies out, this thing is trying to do its job up there, and it might get warm. So if you think you're going to do that kind of stuff, do a double core or a triple core.
Kevin,
yeah.
Kevin, when you wire this, when you're wrapping the wire around, are you trying to keep each coil of wire separate from the adjacent one?
No, they're right next to each other. See?
Yeah, I can see that, but are they not touching?
Oh, they are touching.
Okay.
Yeah. You want them. You want the pairs touched really close to each other. Okay. And you want them evenly spaced. And the same thing on this side. Yeah.
Okay.
That way when it gets the common mode, they're right next to they're actually right next to each other, and it cancels it out. Anyways,
okay.
You want them nice and tight. So if this thing was all spread out and ugly, it would still work. Just wouldn't work as good. I had one that was wound even worse than this one, and I could move it around and I could see the thing going up and down. There's another guy, I'll give credit where credit's due, another YouTube channel. I have not seen any new content from him in about a year, but he is it's called TRX Bench, and his name is Peter, and the guy is really good, and I found him, and he does a tutorial on this particular type of winding, and he also does a tutorial on a couple of other versions, and he does a really good job. And he has a really nice he sets up an analyzer very similar to mine, and he shows people what it's doing. And the difference between mine and his is I built these goofy little boxes, because these boxes introduce error, because of all the connections. So I'm trying to null it out as best I can, and we're operating on the HF band, so you can ignore it to some point. But in his case, what he does is he actually takes some decent coax, which this is okay coax. He cuts the end off, and then he solders his resistors with reasonably, short leads. And then he soldered his test jig, so it was like right here and it was like right on top of it. So if you do that and you test your gear, you test your home experiment that way, and get rid of this convenience thing I built, your measurements will be even better, because there's less reflections, less loss, and less chance of something coming loose. But I did it because I wanted to be able to grab the MFJ one like this, which has a connector, and then I just grab my goofy little adapter right here, just plug it in. Everybody's got BNC to PL 259, just stick it in there. Then I just plug it into the plug and hook the wires up. Is that a laboratory NITS certified way of doing it? No. But is it a really good way to compare what you're building in your shack with your Nano Vna? Yeah, absolutely. By the way, your Nano Vna is going to have SMA connect. I think SMA connectors on it. So you're probably going to want to get some what do you call them, HT savers. And I actually, the geek WG5EEK. I don't know if is he on? Is he watching us tonight? Anyways, he and I bought a bunch of a little pack. We can show you where to get them, and then you can make your own little HT savers so that when you're using your Nano VNA, you can have like a foot and a half of cable to bare wire, so you can do stuff like that without putting any stress on your device. Just a thought. Don't everybody talk at once, please.
Awesome. I've been trying to figure out how to kill the temperature notification, but oh well. Well, awesome.
Are we running is your computer getting ready to take off?
Make it cooler in there. That'll get rid of the temperature notification.
Yeah, I thought setting it at 74C was a good warning, and I'm down from 95 to 93, so.
Well, that's nothing. That's good.
Getting a little bit better. Really Mike says, I think we got them from Electronic Bay.
I don't know, because Mike bought like a bag of them, and he shared, like a half a dozen with me at least. But that's it. They're inexpensive connectors, and they're something you can get. And something too, you guys are going to you're going to learn real fast. This wire size is different from wire, and connectors are different. So it takes a while sometimes to get the right connector for the right cable, so that when you crimp them, or if you're using crimps especially, you want it to be right. I just use these dumb little, for my testing, these are just BNC. I got, they're just little chassis mount BNCs. I got them here. There's little chassis mount BNCs. I got them from Amazon.
Wiggle, 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 wiggle.
Yeah, I'll try not to wiggle it. So those are like 40 cents. I don't know, they're cheap. I got a bag of 10 of them for a couple of bucks. And I use them for this stuff. Amazon is great. Be careful about connectors and some semiconductors off Amazon, because I found out the hard way some of them are fake and they're not very good.
Dang it.
They're not. Yeah, dang it. You get what you pay for.
Man, well that was really good, Kevin. That I think you had everyone sitting at the edge of their seat. And I think we should kind of wrap it up. I'm thinking. Does anyone else have any final thoughts or questions here in the Zoom call? No, great. Well, some people had some other things. Grounding. People seem to be very interested about grounding. So maybe we'll talk about that next, or possibly what is the best. What is a great homebrew antenna? Because I think that goes along with the Ballon. Is you make the Ballon. What's the best performing antenna that you can build with next to nothing? I think that's just a lot of fun. Obviously, you can go buy a lot of things, but maybe we'll think about that, or go down another rabbit hole next. But I think this was definitely well received, and it was great seeing everyone out at our meeting. And we can only hope that we can come hang out in August, but I don't know. They just canceled my kids' soccer, which is in the fall, and so I don't know. We might be locked in our boxes. We actually have the perfect amount of people right now for the Brady Bunch. Brian BXP, I think. Who's in the center? Is it the maid? Who gets to be in the center? I forget. I think there was actually 3 other boxes for the Brady Bunch. But
yeah, I noticed on the chat somebody commented the guys on CW use 2 and 3 cores that use the end-fed end thing like that, and he's right. Whoever that is, you're right, because if you run lots of power, you need it. But like I said, that small one was good to like 300 or 400 watts.
Well, excellent. Well, okay then. I'm gonna say 7-3, guys. Good night. Thank you for joining us. We're here.
Thank you. Wonderful.
Awesome. Yeah. We do go live every Wednesday, so maybe we'll have to book you for one of those, Kevin. Maybe we could get you to commit once a month or something. Get Bruce. It's always good hearing from Bruce and whoever else would like to present, of course. You know, I'm not trying to exclude anyone, but I'm just thinking of some of the people that really throw different things out there. So, okay, everyone can wave in their boxes goodbye. I'm going to kill the streaming button here. Good night, everyone. See you next week. All right.